I was painting my truck some time ago, and the air compressor decided to give up the ghost about halfway through the paint job. And here's the compressor in question. I've had this compressor for over 10 years, and this thing was never great. I never loved it. In fact, there are some things I hated about this thing. And here are the main 3 reasons why. Let's look at the specifications. This motor that's connected to the air pump in here puts out 5 horsepower. The air pump output is 13.5 CFM at 40 PSI and 10.3 CFM at 90, and it was mounted to the top of this 60-gallon tank. These numbers aren't totally terrible, but at the same time, they're not amazing by any stretch of imagination. If you are painting where you are continuously using up a lot of air, the pump on this compressor is just not keeping up with the demand. The second reason has nothing to do with this particular compressor because it actually affects every air compressor on the market, and that's the fact that they all condense water inside of the tank. That in turn ends up in your air lines, and you always want your air to be as dry as possible. No matter if you're running your air tools, if you're painting, or if you're sandblasting, having dry air is extremely important. And number 1 reason I absolutely hated this compressor is because how insanely loud it is. If this thing was running and I walked about a block away from my house, I kid you not, I can hear it running all the way from there. I had to turn the volume on this next part way down. If I'm talking, you guys cannot hear me talk. I have to be so loud. This is an oilless air pump. It's pretty small in size, as you can tell. The pistons inside, they're probably about 2.5 inches in diameter, which is not big at all. And if you look here, there is a seamless transition between the motor and the pump. That means it has a direct drive where for every turn of this motor, this pump will also rotate 1 time. So in order to make up for the small size of the pump, it has to spin at a really high rate of speed in order to build up all of that air pressure. And if we look on the back side, this motor actually spins at 3,450 RPM. And that can only mean one thing. This pump is spinning at that same exact speed. And that 1 cylinder going out was basically the end of this compressor. And sure, I could have gone out and spent $40 on a rebuild kit and I could have rebuilt it, but that would have put me right back to having a compressor that I was never happy with. And this can only mean one thing. I need to come up with something totally different. And a criteria for the new setup has to be greater air output, running much quieter, cutting down on the amount of moisture in the tank, and at least a 60-gallon tank. And in true fashion of this channel, it had to be done on a deep budget without cutting too many corners. First step was to do a quick internet search just to see what's out there these days and what kind of prices am I looking at. And I'm just gonna click the first link that I happen to come across. Alright, Northern Tool, let's look at their air compressors. They got quite a few available, but if we look at the top, we got number 1 seller, number 2, and number 3 best sellers. This Quincy comes with a 60-gallon tank, so does the Ingersoll Rand, but the Quincy in the middle has got an 80-gallon tank. So to be a little more fair, let's go ahead and compare number 1 and number 3. Also, number 2 is quite a bit more expensive. It's actually more than twice the price of the number 3, so let's go ahead and stick with these two. Let's see what we get with the number 1 bestseller. I mainly want to check the air output between both of these compressors. So this Quincy puts out 15.4 CFM at 90 PSI and 15.6 at 40. These are actually not bad numbers. Now let's check out this Ingersoll Rand. And here we see 18.1 at 90 PSI and 15.5 at max. Not really sure what that means. And these are also some really good numbers. I wouldn't mind having either one of these compressors. Both of them put out much more air than my old compressor. But even if I went with the cheaper one of 2, after paying freight and tax, it would still be right around $2,200. And that's way too much money just for an air compressor. And just like most of you, I read reviews on most products that I'm about to buy, just to make sure that I'm not about to buy a piece of junk. Ingersoll Rand is a respectable brand, so you'd think you're buying high quality tool, especially if you're shelling out, over $2,000. But it looks like there are some mixed reviews. You see 126 5 stars and 30 1-star ratings. And if I scroll a bit down, the comment at the very top is at 1 star, and the guy says that his compressor totally failed after 15 months, after only being used a handful of times. And same goes for this Quincy compressor. The guy says that they bought it in November and it was dead by February. That comes to show that even if you're buying name brand expensive stuff, there's still going to be failures. So in a true DIY fashion, I figured, why don't I just build my own air compressor? I bet you I can get it done for dirt cheap. It's going to be as good as either one of the compressors we just looked at, and with some custom touches of my own, I can make this thing even better. And to do that, I need 3 main components: an air tank, electric motor, and obviously an air pump. And unfortunately, I couldn't reuse any of the components off of this compressor. Because the pump is junk, this motor is made to run with this pump, and a mounting plate at the top of this tank is just not big enough to house another motor and a larger air pump. After checking my local classifieds, I came across an ad where a guy was selling this tank with a motor on it for $100. And when I showed up and took a look at it, I realized that he had 1 more compressor sitting in the area. Long story short, I ended up getting 2 of these compressors for the price of 1. So $100 got me all of this. As you can tell, the first compressor got a tank, motor, but no pump. Pump is missing. Second compressor actually is more or less complete, but the problem is this pump is no good. At least that's what the guy said. And by looking at it, this is not really a big pump anyway, so I don't see this thing putting out a good amount of air. In fact, the air output of this pump is very similar to the output of my old busted compressor. Both of these compressors came with a 60-gallon tanks and 5 horsepower motors. And at this point, the last major component that I'm missing is the air pump. After researching a lot of these pumps online, I wasn't really coming up with a whole lot. A lot of these pumps had either low air output or they were of questionable quality, judging by the reviews that I read. Or they were simply out of my price range, as some of them were getting to be pretty expensive. And then as a last resort, I figured I'm gonna check and see what Harbor Freight has to offer. They had 4 pumps available, but the biggest pump that they carry is this 5 horsepower, 145 psi twin cylinder pump. The price on this pump is pretty good, and this thing also has a ton of reviews with an over 88% recommendation rate. So let's go ahead and take a look at the specs. 17.3 CFM at 40 psi and 15.2 at 90. And these are much better numbers than this thing was putting out. Then I spent about an hour reading through people's reviews, and a lot of them sounded like this man's review, where he says that he's been running this pump for about 7 years, it puts out a lot of air, and this thing runs quiet. And after reading some more, I would also have to agree with this next guy, who says that a lot of negative reviews come from operator error, and also people who can't figure out which air fittings to use with this pump. So once you weed out all of the technically challenged people, this 88% approval rate would probably go a lot higher. And with that in mind, I would say that this is a pretty solid pump. This one is definitely the one I'm going with. Cool, it fits. I mainly wanted to make sure that the edge of the pump on this side would kind of line up with the edge of this mounting base, and also on this side I did not want the base of the pump to interfere with the tank inlet, and it does not. It clears it just fine, so we are good here. And here I'm looking at the pulley alignment with the pulley on the electric motor, and it kind of lines up, kind of not, but that's all good, because later on I think I'm going to end up moving this motor forward because I have to have both of these pulleys lined up just perfectly. The air pump pulley is a double groove, and this pulley right here got a single groove, and obviously that's not going to work. The fact that the little pulley is single grooved is not the only reason why it's not going to work. it's also of the wrong size. It measures 3¼ inches. Let's also take a note of a motor shaft, which measures at 5/8 of an inch. And we also need to get the measurement of the big pulley, which happens to be at 14½ inches. The reason we took these measurements is so that we can match up the right size of a motor pulley to the air pump, so it could spin at around 1050 RPM for the maximum air output. First, navigate to a block layer website. Then scroll down to a pulley belt RPM. Click on that. And down in a lower left corner, there are some parameters that we have to change. The large diameter field refers to the large pulley of our air pump. So let's go ahead and put in our 14½ inches. In the next line down, for small diameter, let's go ahead and put in the 3¼ inch diameter of our electric motor pulley. We're going to skip the next line for pulley centers for now. And then down in the RPM small, we have to put the RPM value of our electric motor, and you can generally find that info on the motor's label. Hit calculate, and now let's move over to the right upper corner of the screen. So now with all of the input parameters, we can see that the large pulley is going to spin at 773 RPM, but that's quite a bit below our target value of 1050 RPM. That means that the electric motor pulley is just too small, and the optimal size for it would have to be 4½ inches. And that setting puts us right at 1070 RPM. 4½ inch electric motor pulley is a common size, so it should be pretty easy to find. And the fact that that size of a pulley only puts us 20 RPM above our target number is okay because we're still within the ballpark. Next, I had to get the tank ready. As I was checking things out, I actually took this fitting off of the side discharge port. I looked inside and it looked like there was some oil residue on there. I went ahead and stuck my finger in, just kind of moved it around, and sure enough, my finger got oil on it. This original pump has oil down in a crankcase to basically lube up the lower end of the pump, and as this thing started getting worn out, some of that oil was seeping past the piston rings and it was getting up into the upper part of the head where that oil was mixing with the air that was getting sent down into the tank. So now I got oil in the tank. And that's sort of bad news for me because I am planning on using this compressor for a lot of the auto paint that I do. And when you paint, water and especially oil is a huge no-no in your airlines. So let's go ahead and clean out the inside of the tank. I went ahead and laid the tank down onto its side so I can get an access to the bong on the very bottom. Then I combined a couple of hand trucks to make a makeshift rotisserie out of them. I got the strap basically holding them together, making sure that they will not separate. Then I set the tank down onto my rotisserie just to make sure that this contraption actually going to work. And it did! Next, I dumped about half a gallon of a degreaser into the tank and capped off all of the open orifices. Next, the tank went for a little tumble, and I made sure that every inch of the inside of that tank got hit with that degreaser, including the very top of the tank. I let things soak for about 30 minutes while occasionally agitating the tank, and this is what came out. Looks like oily degreaser with some rust mixed in it. And since I couldn't get a brush inside of a tank to scrub it, pressure washing the insides was the next best thing. After a quick pressure washer scrub, more nasty water came out. And I kept pressure washing until the water that came out was no longer dirty. Well, the tank is clean, however, we may have a problem. And here it is. While draining a tank, a lot of this stuff came out. And this is rust, this is corrosion from inside of the tank. And this stuff got me worried because I really don't want this tank to rupture when it's fully pressurized. It does say extreme duty on the tank, and I'm not sure if that has to do with the tank itself or with the pump that was on it. This sticker says 135 maximum PSI, and I was basically planning on setting my pressure right around there, 135 to 140. So just for a peace of mind and for some extra insurance, I figured I'm gonna go ahead and pressure test this tank. I borrowed this gauge right out of the pressure switch, then I went ahead and removed the switch and installed the gauge right in its place. Next, through a use of a couple of adapters, I installed a pressure washer wand adapter into the side discharge port of the tank. And then for safety reasons, I still went ahead and moved the tank to the far end of my backyard. I will be hiding behind this tree, so this thing will make a great backstop in case something crazy happens. Then I filled the tank with water to the brim until there was no more air in there, and I went ahead and capped it all off. Then I attached the pressure washer wand to the tank, and just with the water pressure that comes to the house, the gauge went up to about 75 to 80 psi. So the original plan was to push this tank up to 210, but it just took one quick squeeze of the trigger and the pressure went up to 240 psi. This is definitely good enough for me. By now, this tank's been sitting pressurized at 240 for about 10 minutes, and I think it's safe to say that this thing is good to go, so I'll go ahead and release the pressure. To be honest, after seeing all of that rust that came out of this tank, I did not think it was going to pass the test. I seriously thought that this thing was going to pop. But since it didn't, and since I went up higher in pressure and this thing still held up like a champ, I have no doubts that this thing will be just fine. So let's go ahead and throw the motor, the air pump, and everything else on this thing and get this thing going. It looks like the weld between the mounting base and the tank failed at some point due to the vibration. Previous owner welded it back up, but it looks a little rusty, so I figured I would clean it up a bit. Now let's quickly address some plumbing. First, I had to mount the air pressure regulator / air water separator so I could figure out the angles of the airline tubing that would be running up to it. After a few trips to the hardware store, I got all of my fittings needed to get all of the plumbing done on this compressor. Everything that I'm running is going to be at least ½ inch of internal diameter. I know this is not the tool for the job, but this is all I had at the time. After a little bit of trimming and fine-tuning, I got the tube fitted in here pretty nicely. Next, I got all of the components prepped up, applied some flux to all of the areas that will be receiving solder, and got everything soldered into place. Made sure that I did not miss anything, and then I went ahead and reinstalled the tube. The mail just came in. In the first box, we have a double groove pulley. It measures 4½ inches across. And in the second box, we got a sheave bushing. It will slide into the pulley and will compress onto the shaft of the electrical motor for that good, solid connection. Lining up the bolt holes. Now drop the bolts in and get him nice and tight, and this pulley ain't going nowhere. Now let's get this air pump permanently situated. I slid the pump to the back of the mounting base and then used some wooden shims to ensure that the large pulley was running parallel to the front edge of the base. Then I marked and drilled the mounting holes and got this pump permanently attached in its place. Motor went on next. To perfectly align the motor pulley to an air pump pulley, you need a straight edge. You have to make sure that the straight edge makes firm contact with the front and back side of the big pulley and a small pulley to make sure that both pulleys are in line with each other. And with everything lined up, now I can take the measurements between the centers of both pulleys, which comes out to 13¼ inches. Now let's go ahead and quickly revisit the block layer web page and enter the pulley centers value. And this is how we figure out what our belt length should be. And only then you can mark out the position of your electrical motor, so this way you can get your new bolt holes drilled out. Then I put the bolts in, but I did not tighten them down. After both belts were installed, with the use of hydraulic spreader, I was able to put just enough tension on the belts before I tightened the motor bolts down. I don't have this air pump plumbed in just yet, meaning I don't have an air line running from the air pump to the tank, because in the manual for this air pump, it says that I'm supposed to be running this thing for about 30 minutes without a load, meaning it's not supposed to be compressing any air. It's supposed to just run and vent the air into the atmosphere, and it's supposed to do that for about 30 minutes, and that's going to be its break-in period. This pump came pre-lubed with a minimum amount of oil, so I have to add quite a bit more before I fire this thing up. You absolutely have to use the correct type of oil. 30 weight non-detergent oil, and this thing is made for air compressors and hydraulic systems. The wiring is all hooked up. It kind of looks ugly, but this is temporary because I'm going to be unhooking all of this after the break-in period to actually, hook up all of the plumbing on the side. So let's go ahead and fire this thing up, and hopefully it works. And this part was the source of most of those one-star reviews on Harbor Freight's website. A lot of people just couldn't figure out how to get the plumbing done, and this is actually pretty straightforward. Pump came with this flared fitting. You don't need it, throw it away. This is a water heater in my garage. You see these copper water supply lines? Well, this is all that we need. It's just that simple. After quick modification, this is what we got. Get it twisted on and it's looking good. I also picked up this inline air water separator from Harbor Freight, and I ended up modifying it just to fit my setup. Sadly, I don't think Harbor Freight sells these anymore. And to mount that separator on the tank, I quickly fabbed up a mounting bracket. Okay, so this separator may hold some water back, but majority of that hot air will end up in a much cooler tank where, due to the temperature change, it will condense at the bottom of the tank in the form of water. And the only way to prevent that from happening is to cool the air before it reaches the tank. You can go out and buy one of these refrigeration units, but they are expensive. And there are people building their own aftercoolers. And all of the ones that I see rely on air to draw the heat away from the tubing. But water cooling is way more efficient than air. And that's why I decided to use water to draw the heat away from the cooling coil. I put this aluminum frame together to give the coil some more rigidity. I also decided to put an extra drain at the very bottom of the coil so it could expel all of the condensed water that would gather at the very bottom. I got the coil all finished up with some quick disconnect union connectors at the top. I put these connectors in just in case if I ever have to remove the coil, in case that I'll ever have to service it. The last thing I gotta do is to attach the vacuum line, get the bucket into place, and get the coil situated and attached to the compressor. All of the connections are made and everything is looking great. All I gotta do is add some water and put on my custom-made bucket lid. So as I'm filming this right now, I can say that this compressor has actually been running trouble-free for well over a year. I use it almost daily, and I gotta tell you, this thing is just so much better than my old compressor. There's really nothing negative I can say about it. It meets all of my needs. You're probably wondering, does this cooling coil actually make a difference? Well, let's find out. This motor's been running for a few minutes, and these are the temperatures that I'm getting. We are upwards of 211 degrees on the hot side, and on the way out, we're at 58 degrees, and the ambient temperature of the tank is right around 50 degrees, so it's only an 8-degree difference between the air that's coming in and the actual tank itself. Man, this cooling coil makes a huge difference. The difference between the air that comes out of the air pump and the air that comes into the tank is 150 degrees. This system works so well that by the time the air gets into the tank, there's really not going to be any condensation taking place in there. So the air that's going to be coming out of the tank is going to be nice and dry, and that means no more moisture coming out of the end of this hose. And also, just in case if you're wondering how that bleed-off valve at the bottom of the bucket works, once the pump stops pumping, it needs to discharge the pressurized system. So it will hiss there for a while, and right at the very end of that hiss, the valve at the bottom of the bucket will open up and bleed off the excess pressure. And any water that's collected at the bottom of the coil will get expelled. The only thing I can add is that now I actually do have a compressor that I love. This thing is way quieter, it builds air like crazy, and the air inside of the tank is bone dry. I would like to get your input. What do you guys think about my setup? Would you do anything differently? Let me know your thoughts in the comment section down below, and I'll be seeing you in the next video here shortly.